In this video, we're going to look at some advanced factoring techniques that will be helpful on the SAT exam. So let's look at some of these expressions that we're asked to factor in this homework assignment. So the first one, number 58, is x cubed plus 64, and we're asked to factor that. The first thing you need to recognize, ladies and gentlemen, is that this is the sum of two perfect cubes. Namely, this is x cubed plus 4 cubed. And we have a formula for that. It turns out that a cubed plus b cubed can be written as a plus b times a squared minus ab plus b squared. And the way I remember that is that this first factor, that sign is the same. This sign is opposite because you're dealing with the sum of two perfect cubes. That sign is opposite, namely negative, and that sign is always positive. So the way I remember it is S-O-A-P or SOAP. Same, opposite, always positive. Let's plug in our numbers for this particular problem. Here, a is going to equal x, and b is going to equal 4. Okay, a cubed plus b cubed. So we're going to have x plus 4 times x squared minus 4x plus 4 squared, and our final answer is going to be x plus 4 times x squared minus 4x plus 16. Next one, x cubed minus 27. Okay, here, folks, we have the difference between two perfect cubes. So it's important to recognize that this is really x cubed minus 3 cubed. Okay. So here, a equals x, and b equals 3. There's a formula for this, and it turns out that a cubed minus b cubed is going to equal a minus b times a squared plus ab plus b squared. Okay, sorry that that's written awkwardly. Same, opposite, always positive. SOAP. Okay, so let's plug in our numbers for this particular problem. Again, a equals x, b equals 3. So we're going to have x minus 3 times x squared plus 3x plus 9. That's it. Next one. Let's jump down here. 8x cubed plus 25. Plus 125, I'm sorry. Okay. Again, first thing you need to do, folks, is recognize that this is the sum of two perfect cubes. This right here is actually 2x cubed plus 5 cubed. We're going to use our formula for a plus b cubed. Same, opposite, always positive. Now we're going to plug in a squared is going to be 4x squared minus 10x plus 25. And that's your final answer. Okay, folks, let's move on to a different set of problems. And let's look at some more complex factoring. Okay, let's look at number 104. So we're asked to factor this completely. So what's the first thing you notice? You notice that x minus 1 is a factor of all three of these terms. Okay, remember, terms are separated by plus signs and minus signs. Factors are separated by multiplication signs. They want us to factor this. That means we turn all these terms into just factors. So the first thing I'm going to do here is I'm going to pull out that greatest common factor, which is x minus 1. That is going to leave us with 12x squared minus 4x minus 5. Okay. We always want to go back and check to make sure we didn't leave anything in here that we could factor out. And initially, I thought that there might be something to factor out because I had a 12 and a 4, but indeed this final constant here does not allow that. Okay, so how will we factor this, folks? This is what you do. You take this first coefficient and you multiply it by the constant, and you get negative 60. And you put this in a box. And then you ask yourself, what two numbers multiply to negative 60 and add to negative 4? Okay, whenever you have a negative number here, you know that one of the factors is going to be positive and one is going to be negative. The fact that these two factors have to add to negative 4 means that the factor that is negative has to be greater than this. So we ask ourselves, what times what gives negative 60 and adds to negative 4? And the answer is going to be none other than negative 10 times positive 6. Then what we're going to do, folks, is we're going to get creative. We're going to rewrite negative 4x as follows. Okay, we're going to rewrite 12x squared. And instead of writing negative 4x, we are going to write positive 6x minus 10x. And then we're going to rewrite the negative 5. Now notice, I could have written negative 10x plus 6x. But I did it this way for a reason. I paired the 6x with the 12 and the minus 10x with the 5. And the reason is I'm going to factor both sides of this equation using what's called factor by grouping. So let me get rid of this, and you'll see the benefit of arranging it the way that I did. I'm going to factor this using a greatest common factor of 6x. That's going to leave me with 2x plus 1. As soon as I see that this is the factor 2x plus 1, I know that that factor also has to be here. So there's going to be some number here, I'm going to put a question mark, that when I multiply it, it's going to give me negative 10x. And that is going to be negative 5. So we're going to have 6x minus 5 times 2x plus 1. Again, once I see the 2x plus 1, I insert it here and I ask myself, what do I put here that when I distribute, I'm going to get this? Now I can factor out the 2x plus 1. And we don't want to forget this initial x minus 1. That's your final answer. Okay, let's do another one. Let's do this one right here. Seven x to the fourth plus 34x squared minus 5. Now, notice something, ladies and gentlemen. Notice that this exponent is twice that. That means this is a hidden quadratic equation, and you could treat this the same way we treated the previous problem. In other words, the previous problem was, once we pulled out the x minus 1 as GCF, notice that exponent is 2 times that exponent, which is a hidden 1. This exponent is twice that exponent. That means we could treat the yellow equation on the left just like we did this white equation on the previous example. So let's do that. We're going to take this 7, we're going to multiply it by this negative 5, and we're going to get minus 35 and put that in a box. Then we're going to ask ourselves, what two numbers multiply to negative 35 and add to positive 34? Because that's a negative, we know that one of these factors have to be positive and the other one has to be a negative. That's the only way to multiply and get a negative. We look at our middle term. Our middle term is positive. Therefore, we know the positive factor has to be greater than the negative factor. And we come up with positive 35 times negative 1. We now rewrite this creatively. And when we do, we try to pair the factors with portions of the equation that we know will allow us to factor. In other words, I put the 35 here with the 7. Now in this case it wasn't as important as the last case, but always ask yourself, how do I write this? Do I write negative 1x plus 35, or do I write it the way I did? Now I'm going to treat these two parts of the equation, or the expression, and I'm going to factor both of them by grouping. I'm going to pull out this should be 35x squared minus 1x squared. So the first thing I'm going to do is I'm going to pull out 7x squared as my greatest common factor on the left side of the equation. That's going to leave me with x squared plus 5. As soon as I see this, I know it's going to be here, so I plant it here. Then I ask myself, what number, when I distribute it to x squared plus 5, is going to give me this right side of the equation? And the answer is going to be negative 1. Okay? If I put negative 1 instead of that question mark and I distribute, I'm going to get negative 1x squared minus 5. So that's what I'm going to insert in lieu of that question mark right there. Okay. Now that we've done that, we can pull out the x squared plus 5 as a common factor, and that leaves us with 7x squared minus 1. And that is how you factor this expression. Let's review what we did. We take this coefficient, we multiplied it by negative 5, we put negative 35 in the box. we came up with two factors that multiply together to give us negative 35 and add up to positive 34x squared. We team the 35x squared with the 7x to the fourth. That allows us to pull out 7x squared. We're left with x squared plus 5. We immediately insert it over here, and we ask ourselves, what number multiplied by this expression here is going to give us this? And that gives us negative 1. We then pull out the x squared plus 5 as the greatest common factor, and we're left with this. Let's do another one. Okay, skip that one. Let's do 110 right there. Okay, we have x to the fourth minus 10x squared y squared plus 9 y to the fourth. Same technique, folks. There's a 1 here. We're going to take this 1, multiply it by positive 9, and that's going to give us positive 9 in the box. There's two ways to get a positive number when you multiply. You can either multiply two positives or two negatives. We then look at the middle term. The fact that that middle term is negative 10 means we have to be dealing with two negatives. So what two numbers multiply to positive 9 and add to negative 10? The answer is negative 9 times negative 1. Okay, so what we're going to do is we're going to rewrite this negative 10x squared y squared creatively using these two numbers. We're going to pair the number with the other coefficients in the equation that we think will allow us to pull out GCFs. So watch what we do. With the x to the fourth, we're going to put minus 1 x squared y squared. And with the 9y to the fourth, we are going to put minus 9 x squared y squared. Okay, so we rewrote this, we rewrote that as is, and then we took the negative 10 x squared y squared and we rewrote it like that. Negative 1x squared y squared minus 9x squared y squared gives you this. Now what does that allow us to do? Well, it allows us to now treat this equation or expression as two halves. First half, second half. And we're going to look for a greatest common factor. That's going to be x squared minus y squared on that left side. The minute we see this right there, we know that's going to be over here as well. Now, we have to figure out what this question mark is. So we ask ourselves, what can we insert here that when we distribute, we're going to get this? Okay, right there it is, right there. Negative 9, if we put negative 9y squared in here, that's going to give us this. Okay. So let's double check. If we put negative 9y squared here instead of that question mark, we're going to get negative 9y squared times x squared, that gives us this. And negative 9 times that gives us positive 9y to the fourth. So that's going to replace the question mark. So let's do that. Right there. Now, folks, it's clear that we can pull this out as a GCF. And we're left with now, in this particular problem, we're not finished, because look what we have going on here. In both of these circumstances, we have the difference between two perfect squares right here. So we have more to do here in this particular problem. So let's erase all of this. Let's move this up here. And let's continue to factor. This is going to be x plus y times x minus y. And this is going to be x minus 3y, x plus 3y. The difference between two perfect squares. That's your final answer. Okay, let's do one more. Let's look at this one. We take this 3, we multiply it by the positive 2, we put positive 6 in the box. Whenever you have a positive number in the box, there's only two ways to get there. A minus times a minus or a plus times a plus. We look at the middle term. The middle term is positive. Therefore, we have to be dealing with this. We have to ask ourselves, what two numbers, positive numbers, multiplied give us positive 6, and when you add them, you get positive 5. Let's try positive 1 times positive 6. This part is satisfied. However, when you add these, you get positive 7. So this is no good. We have to use plus 2 and plus 3. Now, we're judicious in terms of which we pair with which side of the equation. Okay? So we know that that is going to get rewritten as is. We know this is going to get rewritten as is. The only question is, how do we recreate this using these two factors? Well, it's pretty clear that we want to pair the 3 with the left side and the 2 with the right side. So let's do that. Okay. Now I created a left and a right side of the equation or expression where I will be able to factor something out. If I reversed it, if I put the 2 over here, 3 over there, it would not have been as easy. Okay, so let's do that. What are we going to pull out on the left? We're going to pull out a 3x, and what is that going to leave us with? X plus y squared. Okay, again, 3x times x gives us 3x squared. 3x times y squared gives us this. The minute we see this, we plant that over here. We put a question mark. And we try to figure out what this question mark is going to be. We ask ourselves, what times x is going to give us this? It has to be 2y squared. 2y squared times x is going to give us that. And 2y squared times y squared is going to give us that. So this is our mystery number. I'm going to put that in instead of the question mark. Now we're going to pull this out as a GCF. And we are done.